So you can see here a graph paper, a graph plotter actually. To understand some graph and the Cartesian coordinate, we need a graph paper. So I borrowed it. Actually, I borrowed it. So from where we are starting, that there are two black lines. You can see it. Black lines, they are perpendicular actually, and we name it x and y. So what are these x and y? These are the coordinates. Basically, when we are talking about any function, let it be fx. Here, y equals to fx. Here we don't know the explicit form of the fx, but what we can say that y is dependent on x. X is independent, and y is dependent. Then we have to plot in such a way or choose the coordinate system as x here, that is independent here, and the dependent here. Now, how to calculate the points or how to get the mathematical position of a point? This is a box, a box, a box, a box, etc. So if we have this point, consider this point. What we will read it? Look, at first we will look at this point. That is, now it is in 1. So x equals to 1. And when x equals to 1, the value of y is 1. So y equals to 1. Next, let this is the point. So what we can say? We can say that at x equal to 3, y is 2. Y equals to 2. In this way, we can understand any point. What we need. Why I am doing this? Because this is very important for any physical system to understand. And in many exams they give you some plots like these and these, and there is time and velocity. Then you have to calculate in which point what happened or where is the displacement, etc. from graph. So graph is very important thing to understand to solve problems. And one more thing, if you know the graph, then I think you are done. Many things will be very easy for you. So I am just wipe out it, please. Now I am drawing some graph like this and this and this and this. Okay, these are graph. So what we can get it from this graph actually. So we are seeing that this is 0 point, and this 0 point denotes us what if we have to collect the data at x equal to 0, y equals to 1. At x equals to 1, y equals to, y have two values. You can see one, this value and this value. Is that it? And the corresponding these values to all values for 1. So we can say that y equals to uh, anything between 1 and 2. Between. Between y between any value. Any values, actually all values. All values. So this thing where you are getting say single x and multiple y, what do we call it? There is a name. We call it multi-value. Multi-value. In physical system, there is no place or space for multi-value function. You have to understand this because we don't need it actually. For a single point of x that is independent variable, if we have the multiple dependent value, dependent variable value, then it is a physical system. Okay. Now look at this point 2. X equals to 2, we give also y equals to 2. Then I'm writing this x equals to 2 and y equals to 2. Okay. Now 3, still 2. X equals to 3 and y equals to 2 again. Can we say that this is a multivalued function? No, this is not a multivalued function. Then what is the property of this type? And what is the difference between the multivalued and this single valued? Okay, I'm just writing it out for this. Look, if we change x, that means independent variable, our dependent variable does not change. Can you see that? When it is 2, y is 2. When it is 3, y is still 3. That means y is not changing with the independent variable. It means now at that point 2 to 3, y behaves as a constant. It is not multivalued, but it is a constant. We are going some another example, x and y. Let it be the function is something like a straight line. Let it be a straight line. Okay, this is what does it say? At the point 1, you get 1. This. That means what we are doing, that we are dropping some perpendicular and getting y. And 2, at the point 2, this is the point. And we are dropping a perpendicular here, which gives us x value. And then dropping perpendicular to y value, which will give us the y value. And so on. So if you say what will be the value of this point when x value is, let it be 1.3. Let it be x equals to 1.3. How to calculate it? Okay, the same way we will give this one. So corresponding to x, the value of y will be something like this. Let it be 1 to 2. Now let it be this 1.3. This is 1.3 and this is 1.3. So this is the way you can plot any graph. This is the way. If you have points, then put just points and connect them. Or if you have graph, then draw perpendicular and get the point. In case of motion, what is in exam, especially exam you have given. So if you say that this is this point and after that this point and then this, you are very much aware of this type of figure, especially for various exams paper comes this type of. So and one more thing, that y is here v means velocity and x is t. So you have to calculate distance. Calculate distance. To understand distance, you need some problem to I mean formula too. That is, let s is the distance and formula says it is vt. So what we will do it now? Look, when you are thinking about this type of thing, s equals to vt, then the displacement, or sorry, distance will be the area between this. This is the area. This area will tell you what will be the distance. So in a graph, it is very important to calculate the area under the curve. area under the curve. You may think that okay, then this is a hollow thing and we will go through these points also. No, area under the curve means axis and area. Axis and the curve. Axis, this is the axis and this is the curve. Area under the curve. This is called area under the curve. I'm writing again. Area. There is some problem, I think. Okay. Area under the curve. So how to calculate it? This is, you can think that okay, how I will get these formulas because I don't have the formula. I can remember it. Okay, what you can remember is the most important thing. You can remember something else. Do you? You know there is some points. Okay, I mean extending it. It's something changed. Okay, I think you can understand what what I want to do. So how to calculate the area? Look. So this is a complex figure. You can see that it is a complex figure. A complex figure can be divided into smaller pieces. It's simpler one. Let's see. So if we drop here and if we drop here too, we draw some lines. So we can see that this is a triangle, this is a rectangle, and this is another triangle. So the area will be the addition of all of the figures, addition of this triangle and this triangle and this rectangle, isn't it? Be clear. And now you can calculate this area too. This is and this is, you know, this point, this is 0 1, that means 1, and this is 2 1. So 1 into 1 into half. This is the formula of triangle, area of triangle. Now I'm adding next portion, that is this rectangle. This is 1 and this is 1 to 3, that means 2. You got it? 1 and 3. So the difference will be 2. So the area of this box, I mean this rectangle, is 1 into 2. Area. I'm not discussing what is the formula. You know formula. Formula of a triangle and a rectangle. It's very easy, you know. Plus, the third triangle is here. So what will be the area? It is 3 to 4. Let it be 4. 3 to 4. That means 1. And the height 3 to 1 again. 1 into 1 by 2. Area, height into base by 2. So height base by 2. Height base by 2. So we can do it now. Half plus 2 plus half. So 3. If it is v, that means velocity or speed. Let me speed. I'm talking about one dimension only. Speed. And this is time. So a particle moves, and if we plot the graph with its speed and time, then if we get this type of profile, a graph profile, then you can calculate the distance by doing this. If v is in meter per second, p is second, I mean unit, then the distance will be 3 meters. So you can use the graph now. Next step, I will discuss something else.